Today we have Mr. Dishant Shah. Dishant Bhai is having more than 10 years of experience in the design of different types of embedded product. Okay. He has already developed the different types of product which is related to Texas instrumentation as well. And nowadays we'll move on toward the various different product which is related to IoT over here. So now in today's session, Dishant Bhai will give some brief about the IoTs, what do you mean by IoT, and how we can design different types of IoT product. And we'll go for the demonstration of the special product, that is the universal indicator, which they have already designed as their own industrial product. So I would like to invite the Dishant Bhai here. Dishant Bhai, can you please start the session?
Sure. Thank
Yes.
you, Bharat sir, for the for the brief introduction. So, hello everyone. Today we will discuss more on the need of IoT in the present industry and how we can develop the products and what are the points to be considered while designing such products. So, to begin with, first let us understand what is IoT. Everyone will be aware of it stands for Internet of Things, but the main part of the IoT, it is to provide a connecting bridge. It's a kind of a bridge between the existing devices and your internet and server. So we all are aware that there are so many industrial devices available since so many years. So why IoT makes a difference in those devices? So first of all, majority of the industrial devices which are available as of now are not internet connected. Let us say we talk about industrial temperature controller. So they have a front end GUI on the device using the key and a display. So you let us say you want to set the temperature to 50 degree. So someone should be available as an operator or a device configurator which will connect, which will go on the site and can provide the configuration. So what IoT does, it connects you and your devices seamlessly and remotely. So what if I can say I don't have to go at some place and provide configuration. Instead of that, I can configure the devices right now from any place, any location using my smartphone devices like my laptop, my mobile, or anything connected to my server. So that is the IoT. That is the importance of IoT. It provides you the flexibility. As in the corona situation, we might all have observed the new term work from home. So it provides you the flexibility. But for the production industry, work from home is not as easy as it seems for IT industry. So in IT industry, it is majoritarily, it is based on the software only. So you download your software and you can connect and you can start working. That is not as easy for the hardware oriented businesses, specifically for the manufacturing industry, which are highly dependent on your machineries. So to control, to communicate with those machines are very much necessary, and without that you cannot proceed for the production units. So IoT can do a wonders in such kind of application. So that is why IoT is very very important, and the upcoming era will be highly depending on IoT. So first, let us understand what kind of industrial applications can be done using the IoT. So in simple terms, we need to establish bidirectional communication between your IoT devices, your existing machineries, and the user, which may be an operator or management. So how we can do that? So to begin with, let us first understand what is your machinery. There will be multiple type of machineries. That can be your temperature sensors, that can be your any uh, process instruments such as temperature indicator, controllers, PID, motor drivers. All this kind of machineries will be available on site for the production. So what should be our goal? Our goal is to connect your those devices with your server such that you can access devices remotely. So how to begin with? So first we will need a communication module, or for a simple terms we state that as a modem or a gateway which will connect the internet to your devices. So how to communicate with the devices? So for that there will be multiple kind of inputs. The majority and most commonly input is a 4 to 20 milliampere analog output. When I say 4 to 20 milliampere, it also covers the other classes which are 0 to 20 milliampere, 4 to milliampere, 0 to 5 volt, and 0 to 10 volt. So these four are your voltage and current input. Apart from that, there are some communication protocols using which any device can communicate with your existing machineries. So majority of the communication protocols which are used in the industries are based on RS485, RS232, RS422, and CAN protocols. In the industry, RS485 is the most commonly used protocol because it offers a solution to connect multiple devices on a two-line wire only, and you can connect multiple devices at a time. Although you can communicate with only one device at a time, but and you can change the device to be communicated with. So that is why RS485 is a widely commonly used. Apart from that, RS485 is a differential protocol. Means it does not measure the voltage on its communication pin, but your actual signal is the voltage different between these two pins. So because of this kind of differential or symmetrical topology, it offers you advantage of very long cables for the communication. In practical scenarios, we can go for as long as few meters of cables running from one devices to another. So because of this, RS485 is one of the most commonly used communication protocol. And voltage and current protocols such as 0 to 20 milliampere, 4 to 20 milliampere, 0 to 5 volt, and 0 to 10 volt. These are also widely used for various applications. So to establish a communication between your existing machineries and your server, we can develop a gateway which can accept the input on multiple protocols or analog current and voltage signals. Our device should communicate with server. Now to communicate with server, majority we have three kind of options. First, we can have a Wi-Fi network. So we all are aware of how Wi-Fi works. From your ISP, you will get a wired connection, and your modem will convert it to a wireless signals, and we will have a Wi-Fi routers and repeaters to make sure that we have sufficient network at our point of use. This is the most commonly used methodology in our individual's home and even industrial office environments, where your number of devices are not so much limited. So we can have a flexibility of wireless communication, and we can establish a very easy communication setup there. So in everyone's home and office, definitely we all are using Wi-Fi to a great extent in our day-to-day life. So that terminology is not new for anyone. But in industrial environment, when your machineries are there, Wi-Fi sometimes may not offer you a proper coverage because when the devices are in a metallic structure, you might observe some of the device gradients, means you are losing the signals. So at that time, instead of Wi-Fi, Ethernet connections offer you a more reliable and more suitable solutions. Apart from that, when you need a high-speed data, instead of Wi-Fi, you will get a good range and good data speed on Ethernet. But when we are communicating with such devices, generally your data is not so huge. But a connection with using the wired provide you some limitations in the movement of your devices. So that is why instead of Ethernet, Wi-Fi may offer you a better solution. But these all are the dynamic cost depending on the existing machinery's location, how feasible it is to modify the existing network. Depending on this kind of limiting factors, we have to decide which kind of communication mediums we shall go ahead. Apart from Wi-Fi and Ethernet, many devices would use a GPRS based service. In Wi-Fi, all the devices are connected using the same or a different set of networks. But GPRS, it is a different kind of server where you don't need anything else except a SIM card. So in that, your device should have a mechanism to insert the SIM card, and using the established GSM network, your device can communicate it with the server directly. So this kind of topologies, each and every topology has its different advantage and different disadvantage. So let us first compare all the networks one by one. First, we shall go for Wi-Fi, where you have a very easy to modify your already existing network, where you just install your modem and using the existing network you can get the Wi-Fi connection. In Wi-Fi, your communication distance between your device and your router should be minimum to avoid any data loss or any communication loss. So, if you are getting a good strength of any Wi-Fi network at your desired point of location, then Wi-Fi installation is the best. Wi-Fi kind of gateways are very easy to install. So, in majority of the environment, this will offer you a very good advantage of flexibility. Means if I have installed my one device at one point, in any case, if I want to change the location of my modems, it will be very easy. It will be simply plug and play. You might need to configure the SSID, password, and securities for your device to communicate with your existing Wi-Fi router or networks. Apart from that, one thing we need to take care that whenever due to environmental changes like temperature, humidity, or this kind of environmental effects a wireless communication in a worse situation also. So let us say if there is a very humid environment and your Wi-Fi router is far away from your point, then you might observe weakened strength or a weakened signal for your communication. So in such case, we may look for alternate, which is which you can add a repeater to your Wi-Fi network to enhance your strength of the signals at the point where we are planning to install our devices. But in overall conditions, Wi-Fi offers you a very flexible and very easy to use communication medium for your gateways. Second, the enhanced version of Wi-Fi is Ethernet based connections. These kind of connections are very easy where you can modify the networks because you have to run a long cables of Ethernet from your routers or your network to your point of device. But this offers you a one-time. This is a one-time activity where majority you will have to just run a cable and you can provide an internet connection to your device or your gateway. This offers you a very special advantage that communication is almost secure. Means secure in means there will be no change of strength compared to Wi-Fi. So compared to Wi-Fi in Ethernet, you will get an advantage of assured connectivity in a long term. So, but at the cost of a long running cables which are required for the installation as well as it is required some maintenance. We might observe sometimes of loose connections, sometimes of cable cut. So this kind of regular maintenance activities are required for the Ethernet based gateway drivers. So it is highly desirable when you have an limitations of networks. Let's say in some of the pharma industries, the walls are very thick, so your Wi-Fi router signals cannot penetrate those walls. So in that kind of environment, definitely Wi-Fi will not serve you the purpose. So at that time, Ethernet is the best solution so that you can assure the connectivity to your devices. Third option is GPRS. GPRS is highly suitable when you have outdoor applications or the scattered devices. Let's say if in one plant I have a multiple devices to be installed, but all are scattered. A distance between them is far away, and there is hardly any chances of existing Wi-Fi networks to communicate with. So at that time, you might go for a GPRS based activities where your GPRS based gateways will directly communicate with your server using your SIM cards. So this offers you an advantage of independent networks. Means you may observe an internet cut. You might lose some internet connections in the Wi-Fi and Ethernet. But if your signal strength is good, there is very less chance of losing the internet connections based on GPRS based gateways. So GPRS offers you the most important part, that is your connectivity. Second thing, to cut out entire GPRS network is an unlikely event. So you can be assured of a long time connectivity for your GPRS based devices. But at the same time, running cost of GPRS devices are too high, because here we have to provide an internet connection to all the devices. So you have to need a connection like any monthly or yearly recharges, which need to have your communication. So this kind of devices, each and every topology has a different set of advantage and disadvantage. So you should be aware of which topology to be used, which kind of communication should be provided for a particular application. So depending on your application, your availability of existing network, or a flexibility to provide, add or modify your network, and a location, these all devices will affect, and you have to select which kind of communication should be there. Apart from these three commonly used terminologies, nowadays LoRa network is also gaining a lot of popularity among the IoT world. It offers you a long range solutions within the same modules. So you can also consider LoRa also as a part of your development. So depending on the scalability and the necessity of the project, you might select what kind of gateway module should be there. Now, we will demonstrate one module which has got a 4 to 20 milliampere input, as well as 0 to 5. So any voltage and any current input, along with RS485 communication should be provided with this module. And we are going to demonstrate a Wi-Fi based devices. So here, this is our devices. I have kept it open so that you can visualize all the components inside. So on the left side, you can see we have a multiple connections. So this one channel, it is for the RS485. Plus and minus are indicated using for the A and B pins of RS485. Here we have a 4 pins where we have two channel input. So in the same channel, we can monitor two quantities at a time. In the For the demonstration, we have enabled only one channel, but on site you can initiate. You can get the data of two channels. So plus minus are for channel one and channel two respectively. How we can power up this device? So on the other side, we have a communication. We have a power up facility, and we can also power it up with the USB cable. Here we can see a connector for USB. So now we'll first demonstrate how we can configure the devices. So presently I'm wiring up the devices with the USB cable so that I can communicate it on with the terminal screen, and I can show you the data. So presently, for the hardware selection, we should first identify whether it is Wi-Fi, GSM, or GPRS. Sorry, Wi-Fi, GSM, GPRS based connectivity, Ethernet, or LoRa. So what we are going to demonstrate is right now based on the Wi-Fi. Now, this was all about the hardware. But once you have decided the hardware, you have to decide a communication channel between your device and server, so known as communication protocol, as a protocol. So there are various protocols available: MQTT, HTTP, HTTPS. All these protocols serves you a different application. HTTPS serves you a secure communication compared to HTTP. But all these protocols are little bit data consuming protocols. So to save up the data and increase the speed of the communication, MQTT protocol has been implemented. MQTT serves you a different set of protocols which you can run between your device and a server and establish a communication. Apart from that, you can implement some of the securities like SSL and TLS certificates, and you can provide AES encryption decryption between your device and server to maintain this required security between your device and your server. So to begin with, we'll first show you when you how you can configure this device for to communicate with HTTP to communicate with your server using MQTT protocol using the existing Wi-Fi network. So here you can see we have a multiple LEDs and switches. So this first switch is used to configure the device. So what we need to do, first your device should be powered off. We need to press this key and then power on the device. So when we power on, we can see a blue light blinking. It will change its speed and it will stop blinking after a few seconds. So now my device is in hotspot mode. So it has created a hotspot named as Emertech 1. So I need to, sorry, if I'll do that, my connections will be disrupted. I'm configuring the device from the other devices which has a web page based communication. I need to enter the baud rate, which is my 5 likes baud rate right now. So as you can see, right now it is connected with my network Wi-Fi named as Emertech, and I have configured it to with my SSID and password. So in this way, first it will be connected with your network on the initial phase. Now on the other devices, I am connecting it from my hotspot to communicate with my device. Sorry for the interrupt. We had lost the connections. Inconvenience me for that. So right now what we have done, we have configured our device as a hotspot first. So on our configuration page, we can provide the SSID. I'll show you the documents for their SIM. In your mobile and laptop, when you scan, you will get the device SSID. Presently, my device ID is 2K19I0T0 access format. When I connect it using the default password, which is my 1234567890, I can connect with my device. When I connect with my device, it will provide me a screen to configure Wi-Fi. So when I click on configure Wi-Fi, I can communicate with my device and I need to store my SSID and password for the existing network using which my device will communicate with my server. So when I will enter my ID password and save, the settings will be stored in my device. This is very much similar to how we configure our routers in daily life. Once it is done, it will store, and then I have to reset my device. So when it is done, it will communicate with my server using the saved SSID and password. So how the system works? So once it has stored the SSID and password to communicate with the server, we will restart the device. And on the next power up event, it will first connect with that server and send the data on the MQTT format using the established protocol. So how we have established protocols, I'll show you the data. So this is the protocol document for our device. So once we have,
screen sharing करो.
take a minute.
हाँ.
Is it visible now? A Word document, is it visible?
Yes, yes, now it is.
Okay, okay, thank you. So this is the communication protocol network. This is a communication protocol. So what we need, how we have configured the device. All the devices will have a different timestamp. So what we have provided here right now is to first sync a device with your time zone. So what we have, when the device power on, this is the timestamp. Hope everyone can see. This is a timestamp method. My device will ask to register itself on the server, and server will respond with this timestamp to sync a time between my device and my server. So this is how our real-time clock of my device and server will be synced. So this does the two things. First, it will mark the presence of that device, and second thing, its RTC will be synced. So whenever we get the data or data from any devices, we will make sure that all the devices are time synced. After that, our devices have an internal RTC, so it will keep track of time. So on power up, it will first sync up its time, and then it will start collection of data. So how to send a data? So to send a data, it is using a JSON format on a MQTT protocol. So this is our topic name on which our device will send the data. So here you can see this is a JSON format which we have used for our data communication. So here you can see it has a input type of, presently it is configured input type of 4 to 20 milliampere. Its present value is 55. We can set the alarm values, we can set the set points and its span. So this kind of configurations can be done at the time of device configuration when we register the devices, and then our device will send the data. Now at any point of time we want to change the span. Span generally stands for, let's say we are using a 4 to 20 milliampere temperature transmitter. So 4 milliampere stands for which value? That is known as span L. 20 milliampere stands for which value? That stands for span H. So in this configuration, we can say presently it is configured for 0 to 200 degrees Celsius, where 0 degrees Celsius is equivalent to 4 milliampere and 200 degrees Celsius is equivalent to 20 milliampere, and our present value is 55 degrees Celsius. In our devices we have an output for triggering your control devices. For that we have a set point mechanism which is presently set at 60 degree. Apart from that, we have a configuration for alarm also. So you can set alarm high point, alarm low point. Presently these both the values are below the set point, so both the alarms are in off state. So this kind of communications can be established between your low channel, between your device and your server. Presently, this is the format for two channels only. So that is why we have a data structure for two units. So in this way, we can establish a communication between us device and server. On our server, we have to write some script so that this kind of data can be separated. It is known as JSON passing. So data will be passed and it will be stored in the any of the data structure. So now I will put this device with connected with a random signal generator so that we can see how our signal and values from their device can communicate with server. So just excuse us for a minute so that we can connect the device, and then I'll show you how we can see the data on the server. ना ना आणि एक कॉलेज Hello everyone. So we have connected a device with a random source generator. This is our link where we can access our data. So presently we don't have made a dashboard for the graphical representation. That is a front end activity which is generally done in the second phase of the system. So how the presently the system is working, our device is continuously throwing the data on the server, and the data is stored for a one channel in this CSV file. So when we generate, you can see the data in the CSV format here. So as you can see, we are getting the live values from our devices from a random source generator. So you can see the data here. So at every second, our device is adding the data to our live database. So this is how we can get the data from our device to a remote location. So this is a part of a backend activity. Now, what is a front end? In the front end, what generally is done, how a user will be able to see the data. That is your front end activity. So there we can have a customized dashboard kind of mechanism, your graphical representations in the form of some graphs and tables, and a report generation where you can generate the reports in the form of Excel and PDF files. So this kind of data communications can be established. Presently, what we have demonstrated is the data communication from our devices to the server. On the other hand, we can have a mechanism where we can provide you a mechanism to communicate from server to device. Let's say we want to set the set point. Presently, I have shown you that we have configured for the set point at 60. So we can have a mechanism where we can change the set point remotely. So this kind of communications can be established between your device and a server. So this kind of different applications can be made using the IoT. So when we develop the IoT, there is a very important term which is security. When we are connected with the internet present, we all are aware of how there is a constant fear of a cyber attack on commonly devices like your mail applications, your social media accounts. So the same threat or even the higher threat is there on the industrial applications also. uh, there was a time recently there was an incident where tech giant was shut down for a few minutes, and entire Mumbai city, it was their electricity power was lost for almost 2 to 3 hours, and that was entirely connected as a part of cyber attack. So how to avoid, what kind of security measurement should be taken from your server as well as from your devices? So to establish a communication between your device to your server, we need to consider the security at the most important level. So first thing first, your server should have a TLS or SLS based certificates for the security purposes. Second thing, to increase and enhance your security, you can provide a system with the AES encryption. So AES encryption is a kind of encryption mechanism between two known devices. One devices will be your server and one devices will be your actual gateway module. So both the devices will be have a shared key using which the encryption and decryption takes place at both the places. So if someone tries to interrupt the message between those two devices, if even if they can interrupt the message and get the message, but they cannot decode it, so that whatever the communication between one end to another end, it is foolproof. Second thing, your server should have some mechanisms to detect that whether the message is from a known sources or from an unknown sources. So that can be done using the implementation of SHA signature between both the parties, where our one party is your device and other is server. So whenever your any device tries to send a message from one end to another end, it should have a SHA signature implemented. So a SHA signature is nothing but a specific signature assigned with individual devices. So on the receiving end, a system will identify the SAR signature from the message, and it will decode whether the message is from the authenticated source or it is from the unknown source. So in case of unknown source messages, a corrective mechanisms to disable the communication between that device can take place. If not, at least we can prevent that unknown sources should not be able to send messages to our server, or our server should stop receiving signatures without a SAR signature. So this kind of basic, although in the this is just an overview, but due to time limitations, we cannot go into the brief of everything. But just to understand that this kind of security mechanism should be taken care while the design and development of IoT-based applications. So hope this kind of basics are clear to all. And if you have any queries, if you would like to inquire how actual communications takes place between your device and server, what kind of server topology should be developed, how to establish a server, what kind of scriptings are required for server development to implement an MQTT protocol or any other protocol such as HTTP, HTTPS. So this all kind of informations you can, if you want to know, you can definitely get in touch with us so that we can try to identify your queries and resolve it as soon as possible. So we hope you have got a basic idea of how the IoT system works and how you can start the development or what are the needs for the IoT, and you can start working on this field. So hope everyone have enjoyed this seminar. Thank you so much for being with us. Thank you everyone.
Okay. Can we show the some hardware structure, hardware part over here? What are the basic configuration? Listen,
Sorry, repeat your question,
uh,
please.
Can we have some hardware circuitry? Suppose if you have PDF files, so what are the basic components we have used in the hardware?
I will explain you the basics with this device. My screen is visible right now.
Yes, yes, it is visible.
Yeah,
Okay, can you do one thing? Stop sharing, so your complete video is visible here. Uh, s-
sure.
okay, so whatever demonstration you are showing here, because we have 10 to 15 minutes time, so we can utilize it. Yes.
No issues, no issues. So
Yeah. Okay.
the
Uh,
hardware which we have demonstrated right now, the first thing, it has a block to implement the analog signals. So the first part of the system is an analog part. So in analog part, what you need to implement is, it is first thing first. Whenever there is an analog signal, you need to have a line filtering mechanism, a filter which enables only, so which disables your noise to separate from your channels to your ADC. So we have a line filter designed on PCB. It is a low pass filter based on RC concept. So your analog signal which is going for the ADC is a noise free. There are so many calculations which are required to how to design the cutoff frequency and all. So after doing those maths, we can design our RC filter. After output of RC filter is given to the ADC. So for the ADC, we need to consider multiple parameters. What is our sampling frequency? What is the maximum amplitude available of our input channels? And resolution of ADC. So what we have used right now is in 16-bit ADC. For that depends on what is the accuracy level you need. So that kind of calculations you should have at the back of mind. For the higher accuracy, you can go for 20 bits ADC, 24 bits ADC, and 32 bits ADCs are also available nowadays. So depending on your application, you need to select an ADC. After ADC, the process signals from the process signal has been given to the ADC, which is an SPI based ADC. So we have a PIC 18F series controller, 18F46K22 microcontroller, which is used to communicate with the ADC. So basically, that controller fetches the data from the ADC. So whatever is available on our analog end, that analog values are converted to the digital values using a communication between SPI ADC and a controller. So controller will get the digital values corresponding to the analog values. So those analog values are communicated with our Wi-Fi modem. So for a Wi-Fi, we have used ESP32 module from the Espressif. These are the very low cost and highly effective Wi-Fi based modules. We can have very easy and accessible libraries from Espressif. It is Arduino compatible also. So using that module from our peak controller, we have communicated with the ESP32 based on UART. Uh, peak controller is operating on a 5-volt IO lines, where ESP32 is operating on 3.3-volt IO lines. So we need to add some voltage converter circuits. There are so many various ICs available for that. So you can, using those ICs, you can communicate, establish a communication between your microcontroller, which is PIC18F in our case, and your ESP32. So from ESP32, you will get the data on the serial communication from PIC, and then you can communicate with the server. Espressif module is having a Wi-Fi channel, Wi-Fi chip on board, so it can work in a multiple ways. Either it can work on a hot station mode, means it will generate our own hotspot, and you can communicate, you can connect with your device. So that is the mode which we have used when we need to configure our device. In the second mode, it can connect as a Wi-Fi device, and it will connect with the existing Wi-Fi network. So that is the mode which we have used when we are sending our data from our device to the server. So when for the configuration, it is working on a AP mode, and then it can work as a device which can communicate with the server. Apart from Espressif, there are various Wi-Fi modules from Texas and Microchips, and other so many vendors are available. But we have found that ESP32 is the most cost-effective solution. And nowadays, Arduino is very popular among the students and hobbyists and very industrial applications also. So this ESP32 modules are compatible with the Arduino. So you can program those modules using the Arduino, and there are various open source libraries are available so that you can develop your applications rapidly, and you can make a prototype based on the development boards available for the same module, and it will reduce your development time and efforts to a great extent. So your product to reach the timeline of development, to finish the development and come to the market, it will be very much reduced, and it will be an easy path for the beginners also. So apart from these devices, the main part will be your ADC. So as we have some time, we can discuss a lot that how we can select the ADC. The first part will be we need to identify what should be our maximum voltage available on our input pins, and then we need to design a circuit to clamp the and lower limits of our voltages. Second thing, we should consider how many channels do we need in our applications. There will be single channel, double channel, four channel, eight channel. Various ADCs are available depending on the requirement. Second thing, we should also consider whether we need differential data or a single channel, single-ended data. Differential data means a difference between two channels is our actual data. This is very much used for the various communications also, as well as when we need to have a reference voltages for some RTD measurements and thermocouples. Differential data is widely used. So depending on the application, we will select either we need a single-ended channel or a differential channel. Then a resolution. Resolutions is the most important part because it will affect your accuracy of the measurement. Generally, higher the resolution, higher the accuracy. But at the same time, a process time for the ADC, your sampling rate will be lowered. Your process time will be little bit on the higher side as we move on, increasing the resolutions. But and at the same time, also the cost of the 24 bits ADC will be higher than 16 bits ADC. So depending on this kind of mechanisms, you need to select a particular ADC. There are various very standard ADCs are available from Texas Instruments, which you can go through that portfolio and identify. So this kind of ADCs, SPI base, I2C base, even some of the ADCs are available for the UART base also, or you can program it with your any of the micro. Those ADCs can be programmed with any of the microcontrollers, whether they have I2C or SPI inbuilt or not. If not, you can implement the protocol using the bit bank. It's a kind of generating a bit by bit patterns on your particular pins, so that the timing sequence is very much similar to what we need. What we have is a in a I2C or SPI. So in this way, we can select our ADC. We can program those ADCs using our microcontroller. Here we have used PIC 18F46K to do, but you can go for you can go for any basic microcontrollers also depending on your requirement. So this kind of hardware, what we have utilized in this module, is in this fashion. Apart from that we can think of a power modules also. So how to power up the devices? Presently we have two options in our device. One is from the external adapter of 5 volt, and second is from USB cable. USB cable which we have used for the USB connector, it serves the two purposes. First, if we connect with our laptop or any device having a USB, it will power up the devices from the USB. At the same time, this USB is converted to a serial communication module on our board, and you can have a debug mechanism which we have just shown you to have a communication verification between our device and any host or any laptop or some devices, so that you can check. It is very much useful when we are facing on-site issues to debug the issue and resolve it. So this kind of power USB serves you a double purpose. You, although on site, you can power it with the single adapter also. Anything you would like to know more about our hardware, sir?
Okay, thank you. Can you please brief about the some Texas instrumentation IoT hardwares available in the market? Because I know you have very good knowledge on the Texas instrumentation hardware as well. Okay, so can you just brief the some basic hardware structures or hardware which is available in the market, So because those who are from the beginner, they can use or they can start their own project or development which is based on IoT as well.
Definitely. So if you go to the portfolio of TI.com, if you go to TI.com, you will find a separate section for those wireless devices. But I will just brief you about their IoT products. So TI has is a wide range of devices, but the majority which are available on as a development board are from CC320 series. So these are the basic modules where you can have a these devices are inbuilt having an MCU. So for various basic applications, you might not need an external MCU to interface with. This is known as Wi-Fi SoC, means Wi-Fi system of chip. It has memory also, inbuilt memory. It has some security also, security boots which we just talk about, that your device should be secured. So how to secure and how to bootload the devices for the Wi-Fi applications. So if students or anyone wants to start with the IoT development, they can go for this CC series, CC3220 series.